Hi dear students, let's see this question that came in JEE Advanced Paper-1 Physics in the year 2019. This was a simple question from electrostatics based on the concept of electric field and potential of a hollow shell, and this was a single choice correct question, and I am sure that almost all the students in India would have done this question. So let's see what is being asked in this question. There is a spherical insulating shell of radius r which has a uniformly distributed charge. So under this condition, the potential at the surface of the shell has been given as V naught. Now what we are doing is we are removing a very small area from the shell whose value is the value of the area that has been removed is alpha into 4 pi r square, where alpha is a fraction which is much less than 1. And we have to assume that the remaining shell remains as it is. That means the charge on the other remaining part of the shell is as it is. Which of the following statements are correct? So if we see the situation, basically what is happening over here, initially if the situation was like this and the charge was, let us say, uniformly distributed on this, the radius was r, we can assume. So according to the given condition, V naught will be equals to kq by r, right? Now what we are doing, we are removing a small part, let's say from here. So basically a very small part of the charge will be gone, right? The area that has been removed. So basically we can say that dA is the area that has been removed, is alpha into 4 pi r square. 4 pi r square is the total surface area of the shell, and alpha is a very small fraction. So we have to see that very small part of the area has been removed. So now since charge is uniformly distributed on the shell, on the area of the shell rather, so can we say that alpha fraction of the charge will also be removed? Right? Because if you think, then if you say dq charge has been removed, let us say, so we can say that dq will be equals to q upon 4 pi r square into the area that has been removed, dA. So that will become 4 pi r square, alpha into 4 pi r square. So this becomes alpha q, right? So this amount of charge has been removed. So if you think carefully, what are we left with? We are left with this small part of the, yeah. So we are left with this much shell, and a very small tiny part has been removed. Now, to do this question fast, can we think that actually the shell was still full and instead, let us say, a negative charge of this much value has been kept over here? From the perspective of charge, if we think, then is this not the same situation that has been created? मतलब मैं यहाँ पे कह रहा हूँ minus alpha q charge if we put over here इस point पे, so this minus alpha q and that plus alpha q will be neutralized, and we will be left with the remaining shell, if you think, है ना? तो अब let's check the options. This is the center of the shell. If you go to the option 1, ratio of the potential at the center of the shell to that at the point r by 2 from the center towards the hole will be this. तो रेशियो हमें यहाँ पे निकालना है और एक यहाँ पे निकालना है. तो सेंटर ऑफ द शेल पे रेशियो कैसे लिखेंगे? बिकॉज ऑफ द होल शेल we can say that ratio will be V naught because of the whole shell, but because of this minus charge we can say kq by r. So this is a negative charge, so k into alpha q by r, k into alpha q by r. This is the potential at the center, है ना, divided by potential at this point which is r by 2. This distance is r by 2. यहाँ पे potential जो आएगा, that basically because of the whole shell it will be again constant, because whole shell का potential अंदर constant रहता है shell के, so it will be V naught itself minus इस charge का potential which is k into alpha q upon r by 2, so that will become 2k alpha q upon r. r को मैंने r by 2 लिख दिया. अब if you see V naught is kq by r, तो V naught cancel हो जाएगा, V naught kq by r, V naught kq by r. So if you see, we get 1 minus alpha upon 1 minus 2 alpha. Correct. So option A is right, and hence we were not required to check other options since this was a single choice correct question. But here, since we are doing this video for the learning purpose, so we will check all other options as well. The potential at the center of the shell is going to reduce by 2 alpha V naught. We have already checked that potential at the center of the shell actually reduces by the value alpha V naught. You can see over here, this is the reduction in the potential. है ना? तो potential center पे it reduces by the value alpha V naught, and hence option B is wrong. Magnitude of the electric field at the center of the shell is reduced by alpha V naught by 2R. If we are smart enough, we don't have to even check this option. It says that magnitude of the electric field at the center reduces by. Now, if you think carefully, what is the magnitude of the electric field here? 0. So, magnitude can never be less than 0. So, there is no chance of any reduction in the magnitude. So, of course, option C, we don't need to check. But since we are again learning, doing this for the learning purpose, so if we want to if we want to find the reduction in the magnitude of the electric field, so we can say that earlier the electric field was 0. Now the field due to whole of the shell will still be 0. And because of this field, because of this charge, we will have the field k into alpha q by r square. K into alpha q by r square. So that will be the reduction in the magnitude. That will be the increment in the magnitude rather, not the reduction. Okay. Check the, so anyway, this is wrong. So option D, if you want, the magnitude of the electric field at a point located on the line passing through the hole and the shell's center on on a distance of 2r from the center of the spherical shell will be reduced by alpha v naught by 2r. So basically, if this is the hole, this is the hole. So we are talking about a point here, P. Okay. Actually, it is not mentioned whether we have to take P on this side or this side. But as we will see, if even if you take P on the other side, we will the answer is not going to change. That means even option D will be wrong in that case as well. So if you find the electric field initially at this situation, so initially the electric field was K into, let me write the option D over here. So electric field initially was electric field initially was KQ by 2R ka whole square, that means 4R square, correct? Now finally the electric field again we can write due to whole shell and due to this minus Q. So E final will be is equals to KQ by 4R square, that will be due to the whole shell, okay, and due to minus Q will be K alpha Q divided by this distance will be R. So this will be R square, correct? So if you take the difference, you can see this itself is the change in the magnitude. KQ by R ko you can write V naught, and hence we can say delta electric field will be, if you were talking about the change in the magnitude, so it will become how much? KQ by R is V naught, so alpha V naught by R. This is the mod of alpha V naught by R. So KQ by R is V naught and alpha V naught by, yes, that is right. So basically you can see option D is also wrong. Even if you would have taken point P here, then also these two things would have remained the same. And here we would have gotten 3R ka whole 9R ka whole square, because 3R ka whole square would have become 9R square. Then also option D would have been wrong because it says alpha V naught by 2R. So as you can see, option A was the correct question. The question was simple, and I'm sure most of the students in India would have done this. Thank you.